I am going to take part of our stock solution and measure 5 milliliters, and then we'll be putting it in this dilution bottle and then adding the rest of water to the meniscus level. It's the line right. So as you can see here, I am measuring out 5 milliliters of our concentrated stock into our graduated cylinder. We are doing half dilutions, so that way our calculations for concentration will be easier. That's because we are using a 10 milliliter flask. We have to use 5 milliliters each of the solution and the water. This exact procedure will stay true for all of our dilutions. You can see me at eye level, making sure the apex of the meniscus is sitting right at 5 milliliters. The meniscus is the curved surface of a liquid in a container. We measured at the bottom of the meniscus to ensure accuracy. I've provided a picture of what it should look like because we didn't really get close enough. For the water portion, we did not need to use the graduated cylinder. We carefully measured the water so that way the apex of the meniscus was at the 10 milliliter line on the volumetric flask. I have provided a picture to show what that line would have looked like, as it's hard to see on camera. We had to be extra careful because if we overfilled, we had to restart. After mixing, we completed our first dilution.
This is our second dilution.
Here for our second dilution, Allie is doing the same thing as I did before, except this time she's now adding 5 milliliters of our first dilution into the graduated cylinder. And she will later add water to fill up to the line of the 10 milliliter volumetric flask. Whenever we try to get up close to it, you can't really see the line, so that'll be an improvement for later assignments. But she was asking me for help to see if the line was at eye level. And here's that picture again to show you what it should look like. And now you can see that she is pouring it into the next flask. Now Allie is carefully measuring the water with our water pipette and adding it to our second dilution in the volumetric flask. Once again, we are making sure not to overfill and that the apex of the meniscus hits the 10 milliliter mark, otherwise we'd have to start all over. Seconds of this.
Wow.
Because you're at 30. Can you be done? This is 30 seconds
Keep
long.
the dialogue in there, by the
Be
way.
done.
Alright.
Okay.
You've never seen anything.
I'll take off the lid. This is a little bit cloudy, so I'm going to go add a few drops of ammonia to clear it up. Okay, I added the ammonium, so now I'm going to mix. So Elijah is now taking 5 milliliters of our second diluted solution, and he will be putting that in the graduated cylinder, once again making sure the apex of the meniscus exactly hits 5 milliliters. Now Elijah is carefully adding those 5 milliliters of that second diluted solution and adding it into our final 10 milliliter volumetric flask. He's now going to take our water with his water pipette and fill it up to that line, making sure we don't overfill. So to find out the concentration of our dilutions, we first have to find the moles. So we are going to take the grams of the solute that we used and multiply it by 1 mole of it over its molar mass. Additionally, we multiply 1 over its liters, which is just its milliliters divided by 1,000. This gives us our concentration in moles per liter, or M. For the following dilutions, you will repeat the same process, except you will divide your solute in half if you perform the experiment like us, because we did the half dilutions. But I also have pictures of what our dilutions would look like if we did this with a 25 milliliter volumetric flask. These are all of our calculations, and that is the end of our dilution video. All of the pictures that I inserted came from our notebooks from that lab.